Xenotransplantation. Organ transplants have saved millions of lives around the world. Over the years, transplants have become much more sophisticated and now have a very high success rate. The problem is that it is difficult to find organs. People can be on waiting lists for years before receiving their much-needed organs, and many die while waiting. The problem is getting worse, as the demand is increasing while supply is decreasing. The reason for this trend is that the world's population is getting bigger while accidental deaths are falling. Most organ donors are victims of car crashes. They were healthy people with healthy organs who were unfortunately killed. As safety standards and traffic law enforcement improve, fewer people are dying in car crashes. This is, of course, a positive development, except that it decreases the number of healthy organs available to those who need them. So the medical community is now looking to the animal kingdom for organs that might someday be used in humans. To date, however, no doctor has successfully performed an animal-to-human organ transplant, known as xenotransplantation. The first major obstacle is the possibility that the human's immune system will reject the organ. The human immune system is programmed to reject and attack foreign bodies in order to keep the body healthy. Rejection was a problem in the early days of human-to-human organ transplants as well. But over the years, anti-rejection medicines have been developed with great success. Yet these drugs probably will not work by themselves when the organ of a different species is introduced, so further measures need to be taken. Genetic modification of the organ seems to be one way to reduce the risk of complications. For example, pigs, which are a good candidate for xenotransplantation, have a protein called alpha-gal in their tissue. Normally, this protein causes rejection in humans and in our primate relatives, monkeys and apes. But it can be modified to do the opposite, trick the human immune system into recognizing the tissue as human. The procedure has shown success in pig-to-monkey transplants, which makes it promising for humans. After altering the gene, scientists could then clone the pigs and eventually breed them conventionally. Pigs breed quickly and have large litters, so a large supply of organs ready for transplants could be produced this way. One concern is the possibility that the donor organ could contain viruses that would infect the human body. Anti-rejection drugs, which would have to be used post-operation to ensure that the body continues to accept the new organ, weaken the immune system. This makes the person more likely to get an infection. Pigs' DNA, for example, contains a virus that is harmless to pigs but could prove fatal to humans. Fortunately, scientists have identified a type of pig that does not carry this virus as part of its DNA. Scientists are also working on ways to prevent the virus from replicating by identifying the receptors that allow the virus to enter a cell. Another animal that seems likely to be a candidate for xenotransplantation is the baboon, which shares many genetic similarities with humans. This decreases the likelihood of rejection. The main problem with baboon organs is that they can transmit many viruses. In fact, baboon-to-human transplants have been attempted, but the patients died of viral infections rather than organ rejection. Furthermore, unlike pigs, baboons reproduce slowly, like humans. They usually give birth to a single infant at one time, so it would be difficult to breed the numbers of baboons that would be necessary to meet the demand for organ transplants. An advantage of using pigs for transplantation is that to many people, it does not seem as morally problematic as the use of primates like baboons. Of course, some animal activists will argue that it is always wrong to kill an animal for the benefit of humans. But given that pigs are already raised for meat, the idea of using them to save human lives would not present a new ethical issue.